Alright, so question 3 is asking us to use Gauss's divergence theorem to find the flux across the surface. Okay, so it's given us a hint to use the divergence theorem, so that means we're going to make use of the fact that the flux is also equal to the triple integral over the volume of the divergence of the vector field dv. Okay, so we're going to use that. Okay, the surface given by z squared plus x squared plus y squared is equal to 9. Okay, so what does that look like? So x, y, z axes, x, y, z. So x squared plus y squared plus z squared gives me a sphere. Okay. Alright, so I've got a sphere in x, y, z space. Okay, and it's got a radius of 3. Okay, because it's the square root of 9. So it goes out to 3 and up to 3. Okay, turns out if we want to calculate the flux from the surface integral, so f dotted with n hat ds, it's actually a lot of work. It's much easier to use the divergence theorem here. So let's find grad dot f to start with. That's always the best thing to do. So it's equal to day x, day y, day z, dotted with xy, negative xy, and z. So it's equal to day x of xy, which is going to be y, day y of negative xy, which is negative x, and day z of z, which is 1. Okay, so that's my integrand. Now I've got to find my bounds on the volume. Okay, so the volume, we're going to use spherical coordinates because it is clearly a sphere. Okay, so we need to find the limits on rho, we need to find the limits on theta, and need to find the limits on phi. Okay, rho is going to go from the origin out to the radius, so 0 to 3. Theta is going to go all the way around because we're going all the way around in the xy plane, so 0 to 2 pi. And phi is going all the way from 0 to pi. Okay, because we've got the whole sphere we've got to calculate the divergence of. Okay, so this is my integral from 0 to pi, 0 to 2 pi, 0 to 3, y minus x plus 1, that's the divergence of the vector field, and I've got d rho, d theta, d phi, make sure you got the order correct, but I can't forget the Jacobian, rho squared sine squared phi. Okay, so I do have a y minus x plus 1 here, so I need to get rid of that. So 0 to 2 pi, 0 to 2 pi, 0 to 3. I'm going to have y, so which is equal to, remember for spherical, x is equal to rho cos theta sine phi, y is equal to rho sine theta sine phi, and z is equal to rho cos phi. Okay, so that means that y is equal to rho sine theta sine phi, x is equal to rho cos theta sine phi, phi, redo that, sine phi, plus 1 times rho squared sine phi d rho d theta d phi. That's equal from 0 to pi, 0 to 2 pi, 0 to 3. Expand this out, I get rho cubed sine phi sine squared phi, so sine theta sine squared phi, minus rho cubed cos theta sine squared phi, plus rho squared sine phi d rho d theta d phi. Okay, unfortunately I can't separate it out because they're all dependent on each other, or they're all being added. So 0 to pi, 0 to 2 pi, this becomes a quarter rho to the 4 sine theta sine squared phi minus a quarter rho to the 4 cos theta sine squared phi plus a third rho cubed sine phi, from rho equal to 3, rho equal to 0, d theta d phi. So if you think this is complicated, try the other way. It's much more complicated. 0 to 2 pi. I apologize if this is getting a bit complicated, but just got to be methodical. Okay, so 3 to the 4 is 81 sine theta sine squared phi minus 81 on 4 cos theta sine squared phi plus 3 cubed is 27 on 3 is 9 sine phi. The zeros are just going to give me 0, d theta d phi. So it's equal from 0 to pi, 0 to 2 pi. Nice common factor here. I've got 81 on 4 times sine theta minus cosine theta of sine squared phi plus 9 sine of phi d theta d phi. So it's equal from 0 to pi. This becomes 81 on 4. Integral of sine theta is negative cos theta. Integral of minus cos theta is minus sine theta. Okay, sine squared phi plus 9 sine phi from theta equals 2 pi. Theta equals 0. D phi equal from 0 to pi. 81 on 4. Substitute 2 pi in, so cos of 2 pi is negative. Well, in actual fact, what's going to happen here? Yes, I'll write it in. Negative 2 pi is going to be negative 1 minus sine of 2 pi is 0. Then I'm going to have minus of negative cos of 0, which is negative 1, minus 0 times sine squared phi plus, oh, I didn't integrate this with respect to theta, my bad. So times by theta, because when I integrate I get a theta. So it's going to be 18 pi sine phi d phi. Okay, so what happens here is I've got negative 1 plus 1, so that's going to go to 0. Okay, that term, so I've just got 0 to pi of 18 pi sine phi d phi, which is equal from, you can integrate that now, becomes negative 18 pi cos phi from phi equal to pi, phi equal to 0, which is equal to, when cos of pi is equal to negative 1, so it's going to be 18 pi, and cos of 0 is equal to positive 1, so it's going to be minus of a minus, so plus 18 pi is equal to 36 pi. Okay, so a bit tricky, the integration here, got a bit messy, but really it's not overly complicated. You're just going to be neat, methodical. Having said that, I hope I got the right answer. 36 pi. Let me know if I made a mistake. I don't think I did, but I found that the flux was equal to 36 pi. So that's the flux across the surface of this vector field. Now, if you were to do the surface integral, I assure you it would have been a lot trickier than this. So have a go at question B. So that's question 3B. It's fairly similar. Just be really methodical and neat, I guess, so you can see where you made a mistake if you did in your working. Okay, so good luck.